Hello and welcome to this video about areas of quadrilaterals part 1. The learning target for this lesson is to find and use areas of squares, rectangles, parallelograms, and rhombuses. So first, I want to jump into formulas and an analogy. And my analogy has to do with utensils. So normally around the dinner table, you have your spoons, you have your forks. Please don't judge my art. All right. And you have your knives. Now, each one of these utensils serves a purpose. It is a tool, and there's a time when you want to use it and a time when you don't want to use it. Soup is great for ice cream, spoons are great for soups and ice cream and stuff like that. Although salad with a spoon, a little bit awkward. So a fork is really good for other things. Anything you might want to poke into and kind of pick up that way. And then finally, if you need to cut something, a knife is fantastic for that. And so all of these work in tandem together to help you eat a meal and to eat it well. Well, same thing here with geometry and formulas. When we are doing a lot of geometry problems, we just have to know the formulas and know when to use them. So let's go over our formulas. First, for a square. The area of a square is equal to your side length squared. So whatever these side lengths are, because they're all the same, you just multiply them together, you have your area. For a rectangle, your area is length times width. You probably already know that, but just want to go over it nonetheless. Now the thing is, these length and widths, we continue to use these, but we just give them slightly different names. So like when we were looking at triangles, we said base and height, but it's kind of length and width. I mean, it's the same idea, but just a different name, maybe a more appropriate name for it. Now, parallelogram is where we're going to see that. The area for this guy is going to be length times height. All right? Because you could say that this dimension right here is the width of a parallelogram. That's the length of a parallelogram. But if we want to figure out the area of a parallelogram, we need to know its height. We'll get into the why soon. Finally, let's talk about the rhombus. The rhombus has 4 equal sides, but the angles, not so much. Angles, I'm going to put maybe there. You know, they might be equal, but they don't have to be equal. So for example, you tend to see them looking like this, where, not the best drawing, but these are each equal, but these angles are by no means the same. Well, when we're introducing the rhombus, we have to introduce another piece of vocabulary, and that is diagonal. So these blue lines right here, they are considered to be your diagonals. Diagonals. All right, and that's where you go from one end or one corner to the opposite corner. All right, now our area formula for this is going to be the area equals 1/2 diagonal 1 times diagonal 2. Okay? When we do some examples, I think that'll make more sense. We tend to label one of these 1 and then the other one 2, and we just have to multiply them together and times by half. Now, before we get much further, let's talk about the why behind these new formulas. So let's take a look at why these formulas are what they are. Let's draw a parallelogram on this one. So I'm going to make this one go about 1, 2, 3, 4, 5 units like that. Down here, let's go a couple more units, or go down here, but then go 5 units that way. Connect those lines, just like that. Okay, now let's say I were to take from here down to here, took that triangle and I cut it off and I moved it right there. So imagine me doing that, taking that triangle and shifting it. Well, what we have created is a rectangle. In this case, made a square, but which is also a square. But we make a rectangle, and now we just have length times width. And the thing is, this is the same as that, but when we're dealing with parallelograms, we tend to call that the height. So that's why a parallelogram's formula is length times height. It's just about kind of selectively cutting a triangle out of it. Now, the rhombus, this one's a little more confusing, so bear with me here. So let's go All right, boom, boom, we have a rhombus. Now, again, we need to know its diagonals. So what I'm going to do is I'm going to try to color code these and see how well that goes for us. Now, what I want you to imagine is taking this triangle right here and bringing it all the way around down here. All right. Now, I'm going to take another triangle. I'm going to take this guy and do something similar. I'm going to bring it all the way over here. All right. Now, we have to take a look at what we just drew. We have a rectangle. What we need to do is we need to identify the dimensions of the rectangle. First of all, the length of the rectangle is the same as this green diagonal here. So this is the length of diagonal 1. Oops, not I, diagonal 1. Now the height, that's where it gets a little more confusing, but this is still here, and this is the height of that. But the thing is, it's only half of it. So this is diagonal, part of diagonal 2, and it's half of it. Well, now we use the idea of rectangular area. We just have to multiply these two together, and we've found the area of it. So that's the why behind it. Now, let's do some actual examples. So for our first one, let's start off with a parallelogram. And they can kind of look slightly different, where we're told that this is 4, and our height is 7. If we want to find the area, we have to apply the formula. So the area is equal to length times height. Plug in the values that we have, 4 times 7, and we end up getting 28 units squared. Let's try a rhombus now. Again, you're going to be given these numbers, so let's say that this one is 10, and this one is 8. Our area formula is equal to 1/2 diagonal 1 times diagonal 2. Now here's the thing. It doesn't matter which one you pick to be diagonal 1, diagonal 2. You just have to, because we're going to multiply them all together anyways. So I'm going to go 8 times 10. I like using parentheses to kind of help show how all this comes together. I think that's really useful. And then I like to also multiply my numbers first. So I'll have 1/2 times 80, which becomes 40 units squared. And there we go. And I'm assuming you know how to find the area of a rectangle or of a square. But anyways, these are the two new shapes that we're kind of going over here, and that's how you find their areas. Now, these are just half the problems we're going to see. The other half are where we're going to use formulas. We're going to use areas as well to find a missing piece of the formula. So for example, let's say that we have a rectangle. We'll start off with that. We're told that the height is 5, and we're told that the area is equal to 40. And we need to find the length. Well, we use our formula, and the big difference that we're going to have here, so length times width, is that we need to solve for an unknown. Previously, we were just evaluating, crunching numbers, but here we need to solve. So I'll take 40 is equal to L times 5, and I need to use my solving skills. I need to divide both sides by 5. So we got a mirror line going here, and length is equal to 8. There we go. So seemingly straightforward, hopefully at least, right? Now, where it gets a little bit harder is if we're doing something with a rhombus. So let's say that we have a rhombus, and they say that this is 10. This one is unknown, and we're told that the area is equal to 30. Well, we need to figure out how this all works. So this one a little more complicated, because the area is equal to 1/2 d1 times d2. What I would do is, we're given one of the diagonals. I'm going to put that in for d1. It doesn't matter if it's d1 or d2, but it's going to make life a little bit easier. So let me substitute my area. 30 is equal to 1/2 times 10 times d2. Now what I've done is I've effectively put the variable at the very end here. So I don't need to do, or it kind of keeps things a little more organized for me. I can take care of this number crunching first. So take one extra step. 30 is equal to 1/2 times 5, or sorry, 1/2 times 10, which is 5, times diagonal number 2. This is, again, diagonal number 2 is just a variable. I need to get it by itself. It's being multiplied by 5, so I need to divide by 5. And using my mirror line, I better divide by 5 over here. And so I have 6 is equal to my second diagonal. And there we go. So this is the first part of areas of quadrilaterals, introducing a couple new shapes, a couple new formulas, and then also using the area and the formula to find missing dimensions. Good luck with your homework or practice, and let me know if you have any questions.